Hello, all you wonderful people. Welcome to today's lesson where we are going to be delving and digging deeper into reduction formula. Right, so we've been practicing that quite a bit now. And what today's questions will include is numerical angles. So instead of saying sine 180 minus theta, for example, I might just say simplify sine of 120 degrees. So we are going to use our knowledge of reduction formula and special angles. So special angles related to your special triangles, right? To determine the value of trigonometric expressions without a calculator. That is very important, grade 11s. We are not allowed to use our calculator here. We need to show our workings. So if I work through our first example, we are going to simplify sine 240 degrees to a numerical answer. Now, without using your calculator, because if you type this into your calculator now, just check what you get. If you type this into your calculator says that this simplifies to negative root 3 over 2. Okay, that's great. But if you just put that down as an answer in a test or exam, I would not be very impressed with you. You need to show your work. So let me show you how to show your work. It's pretty easy, guys. So this is the first thing I do. 240 degrees. Where is 240 degrees on the Cartesian plane? Right? You should agree, it's in quadrant 3, right? It's between 180 and 270 degrees. So that's the first thing I do. I identify my quadrant. I'm working in quadrant 3. We know that quadrant 3 is the 180 plus theta quadrant. So grade 11s, tell me, how can you rewrite 240 degrees as 180 plus something? So 180 plus 60 is the same as 240. So 180 plus 60 degrees, this is equivalent, right? That says 240, that says 240. So all you've done is you've rewritten it as 180 plus an acute-sized angle. The whole point of reduction formula is reducing down to an acute-sized angle. So now we can go to our next step, which is when you are in quadrant 3, we know that this is where tan is positive, but sine and cos are negative in quadrant 3, right? So now when you apply your reduction formula here, so you used to seeing 180 plus theta or 180 minus theta. Now instead of theta, I actually have a numerical angle, and I'm going to reduce down to that numerical angle, knowing that in quadrant 3, my function is negative. So I reduce down to negative sine of 60. Now using your special triangle, sine of 60 is opposite over hypotenuse. So my answer for this is negative root 3 over 2. And right at the beginning of the question, I said if we just punch this into our calculator, wasn't that the answer that the calculator gave us? Yes, it is. Isn't that easy peasy lemon squeezy? So if I run through it again, you take the angle you've been given, identify your quadrants. That dictates, is it 180 plus, 180 minus, 360 minus? Then whatever quadrant you're in, remember that your function will either be positive or negative. Reduce down to that acute angle. Use your special triangles. Boom, there's your answer. Pretty flipping cool, I think at least. Okay, so let's try a second juicy example. How about I throw this at you? Cos of 330 degrees divided by fractions, tan of 135. We don't let fractions bother us, right? Okay, so let me work through my steps. 330 degrees, where are you at? 330 degrees is in quadrant 4. Hey ho. 135 degrees is in quadrant 2, between 90 and 180. Awesome. So I've identified my quadrants. Quadrant 4 and quadrant 2. Lovely. So in quadrant 4, that's the 360 minus theta quadrant. So you ask yourself, grade 11s, 360 minus what is going to take me to 330 degrees? So cos of 360 minus 30 is equivalent to 330 degrees, right? They're both saying the same thing. How about tan 135? Well, in quadrant 2, that's the 180 minus theta quadrant. So 180 minus what is 135? And you should be going, it's 180 minus 45 degrees, Claire. And I'm going, yes, you genius. Yes, you're right. Well done. So now, what's the next step? Okay, in quadrant 4, is cos positive or negative? It's positive. Okay, so it's going to pop out as positive cos, now reduce down to the acute angle. So that just becomes positive cos 30 divided by, right, in quadrant 2, is tan positive or negative? We know it's negative, right? So it's negative tan. And then what do? Reduce down to the acute angle. So that becomes negative tan 45. Pretty easy. So now that we've got these little juicy numbers, we go to our special triangles, and I go, so cos of 30 is equivalent to sine of 60, by the way, because of cofunctions, yes. So cos of 30 is also root 3 over 2. So cos of 30, root 3 over 2, divided by, so I'm saying the same thing, right? If I use a divide sign or that line, negative tan 45. So tan is opposite over adjacent. So negative 1 over 1, or just negative 1. So anything divided by negative 1 would just stay itself, but this will become negative root 3 over 2. Hey ho presto, you've answered the question and you are amazing. Well done. So in my next example, I'm going to go from step 1 straight to this step over here. This step in the middle, it's not really necessary to show this step. And the more we practice this, you're not going to need to rely on this step anymore, grade 11s. It's just for now, while we're really getting the hang of it. Okay, but in my third example, I'm going to talk through the second step, and we're just going to jump to our third step. So let me show you how we do this. Cool, so let's have a look at our third example. All right, sine of 160 divided by cos 250. Cool, so 160 degrees. Which quadrant am I in? I'm in quadrant 2. Okay, so for now, I'm still going to do this to help us. I'm in quadrant 2 with 160 degrees, and 250 would be in quadrant 3, right? Between 180 and 270. So I'm working in quadrant 1 and in quadrant 3. Okay, so like I said, we're just going to jump now. We're going to jump to that third step. I'm not going to do the step in between. So 180 minus what is the same as sine 160? Well, sine of 180 minus 20 would take me to 160. So look at grade 11s. I'm going to do everything in one step. I'm in quadrant 2, so sine is positive in quadrant 2. 180 minus 20 is the same as 160. Okay, so I just did that in one step, and we know now that these are equivalent. They have the same value. This is just the reduced down value of sine 160. If you really like putting that middle step down, you are welcome to. All right, you don't have to do it this way. Cos 250. Okay, so that's the 180 plus quadrant. So 180 plus what is the same as 250? Right, 180 plus 70. So in quadrant 3, cos is negative. We just said we're going to go 180 plus 70, and we reduce down to the acute size angle. Okay, so this is now what we're left to simplify. And now you're going, oh goodness gracious, Claire, 20, 70, these are my special angles. And I'd go, you are 100% correct. So how can I simplify this further? Something should be jumping out at you. Look at these angles. 20 and 70. What do 20 and 70 add up to? They add up to 90 degrees. So we know that when I'm working with sine and cos, when the angles add up to 90, this is when we use co-functions. Amazing, right? So you can decide which, if you want to switch the numerator or the denominator. I'm going to leave sine of 20 as it is in the numerator. Now, cos 70. Cos 70, so that's in quadrant 1, right, between 0 and 90. So I can rewrite cos 70 as cos 90 minus 20. All right, because 90 minus 20, let me write it here. So 90 minus 20, we know that that is 70 degrees. And we know that in quadrant 1, all your functions are positive. So when it switches to sine, it would switch to positive sine 20. Remember, we reduce down to the acute angle. So it switches to positive sine 20, but it was negative to start off with. And we know that a plus and a minus makes it a minus. So cos of 70 is the same as sine of 20. So negative cos 70 is equivalent to negative sine 20. Now, these are exactly the same. And I get a nice, juicy, easy answer of minus 1. And again, if you wanted to, go punch it into your calculator should say this simplifies to minus 1. Aren't these questions actually quite fun? I really enjoy it. Let's try one more example. Okie dokes, let's have a look at our last example. And I need to chat a little bit about these negative angles over here. So let's just deal with this first. Before we start identifying quadrants and reducing down to acute angles, let's just talk about these negative angles first. So negative angles, we're dealing with quadrant 4 then, right? So I haven't drawn it on our cast diagram, but this is the negative theta quadrant, right? It's in quadrant 4. And we know that quadrant 4 is where cos is positive. So when we just remind ourselves for the negative angles, for sine of a negative angle. So for instance, sine of negative theta, that would come out as negative sine theta. For cos, remember that we've moved into its quadrant. So cos is the only one that pops out as a positive when we simplify the negative angle. But for tan is the same as sine, right? We're working in quadrant 4. That's where tan is negative, sine is negative, but cos is positive. So tan of negative theta would be negative tan theta. So we're going to deal with those negative angles first before I start reducing down. So tan of 240, I'm just going to leave it for now. So sine of a negative angle becomes negative sine and the angle, which in this case is 280. Right, in our denominator. So tan of negative 30, thinking of our negative angles, that will become negative tan 30 degrees. Now, cos of 370, that's interesting because 370 degrees, if we think about our cast diagram, right, which runs from 0 to 360, 370 degrees would mean we're starting a new revolution. So we're actually working again in quadrant 1. So I'm going to teach you a very handy trick. When you have angles which are bigger than 360 degrees, all you're going to do is subtract 360 from the given angle. And you're going to subtract until you have an angle which lies from 0 to 360. Because basically you want to be on this cast diagram, right? Working with angles between 0 and 360. So if your angles are bigger than 360, subtract until your angle lies in this range. But you can clearly see as well, we're in quadrant 1, so we know that this will come out as positive. So let me just show you that step. So I'm doing quite a few steps here. We can do it more quickly, more efficiently, but just for clarity, I'm going to show you what I mean. All right, so this for now, we're just going to leave as is. We're just going to deal with that angle bigger than 360. All right, so we have our negative tan 30 times. Okay, so you go cos, then you take your angle that's bigger than 360 and you subtract 360 degrees. And that will simplify to cos of 10 degrees. You agree with me? 370 minus 360 is cos of 10. So I've shown you what that step would be. I'm just going to give you our simplified version. So that would be cos of 10 degrees. Cool, so now we can actually get to simplifying this down to a numerical answer. All right, so let's go through this. 240 degrees lies in quadrant 3, where tan is positive. So I know this will be positive tan, and then I say it's the 180 plus theta quadrant. So 180 plus 60 would take me to 240 degrees times. All right, negative. So that negative is there from working with the negative angle, which we know since we're in quadrant 4, sine will come out as a negative. Now I'm going to deal with sine 280. Okay, so 280 degrees would lie in quadrant 4. So we know that in quadrant 4, our sine function is negative. So it's negative sine. Now, 360 minus 80 will take me to sine of 280. So that simplifies to negative sine 80. And we can see here that we know that that will become a positive. If you wanted to, at this step, we could have also used our co-functions idea. And from 270 degrees, we could have said sine 280 or 270 plus 10, and then we could have straight away switched to cos using our co-functions. But I'm just going to keep using reduction formula. All right, so at the bottom, we already have the acute angle, negative tan 30, and cos of 10, the angle is also acute. So I don't need to simplify those any further. All right, let's wrap this up. Tan of 60, all right, so tan of 60, opposite over adjacent, so tan of 60 is root 3. All right, times positive sine 80. All right, so remember now that sine of 80, well, 80 degrees is not from my special triangles, correct? But I see this juicy 10 degrees sitting in the denominator and 80 degrees in the numerator. And what do those add up to? 90 degrees. So we're going to simplify those using our co-functions. Okay, but let's not get ahead of ourselves. We need to deal with negative tan 30 first. So tan of 30, opposite over adjacent, that's going to be negative 1 over root 3. So, like I said, this idea here, with your co-functions, I'm going to rewrite cos 10 as sine 80. We know that those are equivalent in value. And if you want to check, punch it in on your calculator. Type cos 10, type sine of 80. Okay, so now this is lovely because those can cancel out. And what's left over, grade 11s? We have root 3 divided by negative 1 over root 3. What does that become? That will be root 3 times negative root 3 over 1. And we know that if we multiply those two surds together, your final answer is just going to be -3. Isn't that awesome how something so hectic looking simplifies down to such a simple, easy answer? And that is really why I love Trig. It's such a beautiful chapter. Thank you, grade 11s, for watching and listening, and I hope you had fun and you enjoyed the lesson and get stuck into those questions now. Let's nail this section. Till next time, bye-bye.